Okay, this is a nice paper that points out some technical details of what is happening and what needs to happen if we want to really track climate action, emissions, and progress towards global warming targets, however you want to think about it. So, aligning climate scenarios to emissions inventories shifts global benchmarks. What do we mean by this? This came out at the end of last year, 2023. Taking stock of global progress towards achieving the Paris Agreement requires consistently measuring aggregate national actions and pledges against modeled mitigation pathways. Mitigation pathways coming out of IPCC assessment reports are focused on all the things we need to do to stay under 1.5 or 2, and what will happen if we exceed, how far we can go with business as usual, and so on. However, national greenhouse gas inventories, NGHGIs, National Greenhouse Gas Inventories, and scientific assessments of anthropogenic emissions follow different accounting conventions for land-based carbon fluxes, resulting in a large difference in the present emissions estimates. A gap that will evolve over time, in fact, if we are not careful. Using state-of-the-art methodologies and a land carbon cycle emulator, we align the Intergovernmental Panel on Climate Change assessed mitigation pathways with the I'm having trouble saying NGHGIs to make a comparison. We find that the key global mitigation benchmarks become harder to achieve when calculated using the NGHGI's conventions, requiring both earlier net zero CO2 timing and lower cumulative emissions. We'll see the curve in a minute, but we have seen it in many other podcasts already about how we need to start bending the curve and reducing emissions if we want to stay, true to the global warming targets. Furthermore, weakening natural carbon removal processes such as carbon fertilization can mask anthropogenic land-based removal efforts, with the result that land-based carbon fluxes in NGHGIs may ultimately become sources of emissions by 2100. Our results are important for the global stocktake, suggesting that nations will need to increase the collective ambition of their climate targets to remain consistent with the global temperature goals. I've talked about this global stocktake in the same series or somewhere that you can look up. There are many detailed figures that I won't go into because I want you to just remember that there are issues of how inventories are being done and how climate scenarios are charting the pathways, and they need to match up to do the proper tracking of global baselines and progress. Misalignment between NGHGIs and scientific models. Differences stem from definitions of managed land and the carbon fluxes that are included. So here you have land with extensive human activity, other land serving production, ecological and social functions, and land with limited or no human activity, protected in some way or too far remote, whatever. So you have various estimates. So NGHGI convention based on observatories and scientific modeling conventions based on models of the carbon cycle. So here we are looking at scales. Orange plus this bluish color should add up to green, so enabling like for like comparisons between two conventions. Scientific models red do not currently match NGHGI's, resulting in different emissions inventories. So here is what NGHGI inventory would give you, but this is what the models are doing. So there is some missing sync, let's say, or missing link. To align them, indirect fluxes in blue that occur on all land considered managed in NGHGIs simulated with vegetation models need to be added to direct fluxes calculated with bookkeeping models. Okay, so I want to read all these details here, but here you have managed, so you have what needs to be added to match the models. Managed and unmanaged, there is a difference. So here human bookkeeping models track carbon fluxes caused directly by human activities, so that's this one, and direct fluxes are giving you something, so there is a mismatch. Vegetation models simulate fluxes caused by environmental changes, for example carbon fertilization, and there are already many papers arguing about carbon fertilization, whether it's working or not, and so on. And here is climate, so you can see where the indirect fluxes come from to align the two. So unmanaged, not included NGHGIs, unmanaged, not included in alignment factor. So here's the alignment factor to match models with observation-based inventories. So obviously that will shift the pathways to get there. So you see that land use change forcing emissions, model reporting inventories, and what you do if you do NGHGI reporting conventions. So you have to drop your way off. These differences can grow and can go from positive to negative by 2100, and this is the carbon cycle uncertainty in the models. And as you go forward after a couple of decades, you begin to have scenario uncertainties, so model uncertainties dominate. So this happens in climate as well, but here we're looking at emissions in gigaton CO2 per year, and even there the carbon cycle uncertainty is going to add to scenario uncertainties as well. Okay, so model convention estimates higher LUCF fluxes. NGHGI convention estimates higher. So if you go in this direction, so this is again gigaton CO2 per year. Depending on where you end up with these different calculations for 1.5 and 2 degree C targets, you end up with different estimates of forcing from land use and land use change. Some details, technical details. Basically, forcing is the imbalance or how the radiative balance at the top of the atmosphere is affected by land use change, and how that is affected by the mismatch between what models do and what observation-based greenhouse gas inventories do. And remember, each nation is doing its own thing, and then you have to add it up to global numbers. Okay, so what is the main message? Changes in global mitigation benchmark across assessed scenarios. So you have 1.5 degrees C, this is the number of years you will take to get there. So there is a range, obviously it's a distribution, so this will give you 2. So let's read what these are. So you are looking at number of years, percentage, and the amount of carbon gigatons CO2. Changes in global mitigation benchmarks across assessed scenarios. A to C, scenario-wise distribution of the estimated change in the net zero CO2 year. So when you have to hit net zero, if you do different targets, 1.5 and 2, and 2020 to 2030 CO2 emissions reductions needed in here in B, and cumulative emissions until net zero left in terms of the budget. Remember, the warming is linearly proportional to cumulative carbon, so that way you can estimate how much is left. You have to be careful because of all these sorts of uncertainties. Okay, C is between so cumulative emissions until net zero CO2 shown here between the reanalyzed model-based and NGHGI's LULCF accounting conventions shown here for 1.5 degree C, 1.5 degree C OS, so those are different scenarios. That's IPCC category in green, and 2 degree C. Basically it is just saying that everything you are doing in terms of number of years before which we have to hit net zero, and the targets we have to meet by 2030, and the room left for how much more we can emit, they are all affected by matching or mismatch between the NGHGI forcing and the way models do it. It's not that they are not saying models are incorrect, they are just saying the two methods are very different. So the future role of indirect fluxes in national climate targets, basically you have care is needed when national climate targets rely on indirect fluxes. So you are, carbon cycle is uncertain enough, and then you have technically just different ways in which models are tracking CO2 emissions over the years and how actual inventories are being done based on the definitions of managed land, unmanaged land, and so on and so forth. So this is just some details of where you will all end up. Am I going to read all the details? Not really. So you will just read some messages here. This is the carbon dioxide removal characteristics in mitigation and current policy pathways. Just another consequence of doing things differently. So total carbon dioxide removal, land carbon dioxide removal, and non-land carbon dioxide removal in terms of gigaton CO2 to stay under 1.5 by 2030 versus 2 degrees C. You have to draw more if you want to go to 1.5 by 2100. You get more room in terms of allowing more CO2 to build up. 2050 where we have to go, and 2100. Obviously this is showing now the indirect removals, land CDR, and total land removal. So scenario uncertainty and carbon cycle uncertainty. What is the message you want to take? Again, models must reconcile with the way greenhouse gas emissions inventories are being done, and models keep integrating forward, and they are telling you where we need to be in terms of tracking the global warming targets, how much CDR is needed. So the two estimates can be very different based on just the models versus NGHGIs. Okay, so balancing practicality and policy advice is what it all comes down to in these technical details. We provide here an estimation of the LULUCF emissions consistent with NGHGI's accounting conventions for all IPCC assessed scenarios that provide sufficient land use cover information using probabilistic and constrained estimates from a single established model OSCAR. So you still rely on models to combine all the observations to produce inventories, but still that is inconsistent with what the assessment report models are doing. Repeating this work with additional models would increase the robustness by averaging model biases and structural uncertainties, although this would require land use scenario information at a much finer resolution than 5 regions. Because the pathways are aligned, so there's some details there I skipped, you can look it up. Because the pathways are aligned with the NGHGI's conventions by reallocating indirect carbon fluxes caused by environmental changes to anthropogenic fluxes, our results do not change any climate outcome or mitigation benchmark produced by the IPCC, but they provide a translational lens to view those outcomes from the perspectives of national emissions reporting frameworks as deployed by the UNFCCC parties. So there are two tracks. Model group goes with the IPCC, FCCC is driving the practical aspects like inventories, monitoring, reporting, verification. For example, the fact that we find net zero timings for 1.5 degree C pathways advanced by up to 5 years compared with the IPCC assessed benchmarks does not imply that 5 years have been lost in the race to net zero, but that following the reporting conventions for natural sinks used by the parties to the UNFCCC results in net zero needing to be reached 5 years earlier to match the modeled benchmarks. Our results reinforce the importance of a rapid decline in fossil fuel and industry emissions in this decade, so by 2030, while limiting reliance on nature-based solutions that can weaken over time to keep global temperature rise within the limit prescribed in the Paris Agreement. So some detail there, again I missed. Nature-based solutions is where you are saying you manage forests, grazing, agriculture, generally all land use, including urbanization and wetlands, peatlands, so on and so forth, to mitigate climate change. But they are not going to keep on mitigating forever. In the initial implementation, you may offset some emissions, but over time, they are just sitting there and not doing additional drawdown of CO2 necessarily. Okay. Importantly, this new net zero year is conceptually consistent with the meaning of balancing of sources and sinks of greenhouse gases as stipulated in Article 4 of the agreement, although in the context of CO2 alone, not greenhouse gases altogether. Yet it occurs before the climatological milestone that results in halting further warming, as is the case of the net zero year under the scientific modeling convention. Understanding and addressing how these different frameworks can be mutually interpreted is a fundamental challenge for evaluating progress towards the Paris Agreement, given the reality that carbon removals from anthropogenic and nature-based or natural land-based processes cannot be estimated separately by the NGHGIs, which are typically based on direct observations. So when you offset something, it's a counterfactual world that you will need. You cannot directly estimate how much was offset, right? So the outcomes presented here highlight that the conventions by which land-based carbon removals are considered have important implications for NDC assessment and transparency, operationalization of removals under carbon markets as laid out in Article 6.4 of the Paris Agreement, and monitoring, reporting and verification of these removals. So it's very critical that we make sure we are following, if you use models as a guidance and you are doing CO2 inventories which are mismatched, then these differences will build up. That's the main point. The policy and scientific communities can take steps to meet this challenge by reconciling terms, definitions and estimates of land-based CO2 fluxes in 4 concrete ways. First, climate targets can be formulated explicitly for areas of critical mitigation action, including gross CO2 emissions reductions without LULUCF, net land-based removals, engineered carbon removals, and non-CO2 emissions reductions, allowing for parties to define their expected contributions and to measure progress in each domain separately. That's a long sentence, but please read carefully or listen again to make sure you got all the points. Secondly, parties can clarify the nature of their deforestation pledges, because direct and indirect carbon fluxes vary greatly in different forest types. Just because you're doing afforestation or reducing deforestation doesn't mean the CO2 inventory is the same for all forests. Thirdly, scientific and practitioner communities can convene discussions on how to enhance monitoring, reporting and verification of LULUCF fluxes to better align estimates from both groups. Fourth, integrated assessment modeling teams can provide their individual assumptions and estimates of direct LULUCF, land use, land change forcing, emissions and removals, including the indirect flux components consistent with the NGHGIs and their assumptions about the land use contribution of NDCs and long-term strategies. A lot of words, and you may lose the details because there are a lot of technical things, but basically we need consistencies between the NDCs and how they are doing inventories and what the integrated assessment models which are providing scenarios are doing. Future IPCC assessments could either use such scenario data if available, or use an approach such as that presented here to provide a holistic scenario assessment aligned with the NGHGIs and better inform necessary collective action to meet global climate goals. So it's a bit technical, but I hope you get the main message. I am including it because it's an important point, and often we are using carbon cycle to say we have only 10 years left to save the world and so on and so on, which are just misleading because there are lots of issues on how we are doing carbon cycle, how we do the inventories, how we estimate room left for reaching certain warming thresholds, and so on and so forth. Okay, see you in the next topic.